Good evening. Welcome to class. Glad y'all can make it. So tonight, first of all, I just want to make sure that everything's working okay. Michael Hall, can you hear me?
Yes, sir.
Very good, thank you. Um, Tonight, what we intend to do, first of all, is I'm going to go through just a couple of housekeeping things, show you a couple of things on capacitor that I want to make sure that you're aware of. And then we're going to go into a little bit of teaching time on Article 430, motors and motor control. And that will be our class for this evening. As I'd said in orientation, our intention is that our goal is more student engagement in our e-learning classes. So, many of you should already know that you have a schedule that we'll be hitting um, every couple of weeks, something like that, as far as um, Teams meetings like this, Zoom meetings, whatever you want to call them, virtual. So we'll have those throughout the school year. And there also is the possibility that we will have additional ones beyond the schedule. So, first of all, I want to say I am hopeful that everyone has their books by now. If you have not, it may be that they went to your contractor and they're coming out from that point. Um, but at this point in time, I'm not aware of anyone probably in this class at this level that wouldn't have them. There were some that went to a contract in Ohio, but they should really have them by now. So whether or not they've, you know, sent them out to those students yet or not. I think in that grouping there was only one third year student in those books that went to Ohio that um, needed to be taken care of at this level. Um, so what I'm going to do first is I'm going to start out. I'm going to start out and do a little bit of where are some things on capacitor, because I know in these classes we have some guys who have maybe been with us since the beginning, and you're in your third year in e-learning, and some of you might be transplants or transfers from other programs. We get that a lot, and things change in a 4 year period. So I wanted to make sure that everybody understands how to navigate the site, and I wanted to kind of show you some stuff that you may or may not know. So I'm going to go to classes, and my desktop is going to look a little bit different than yours because I have all the classes throughout Kentucky. You will probably have just one band that says, here's, this is your class. Mine says view class. Yours will say enter class, I believe it is. So, if I go into this, this, of course, is all of your assignments. And they are open all the way up to Article 502, Class 2 hazardous, and that's what you need to have accomplished by Christmas. So, beyond that, New Year's Day, that's when I'm going to open up. Your first assignment that'll be open will be Article 511, commercial garages. So that's how that's going to roll. Um, and of course, I would only assume that I would hope that many of you have already started on your assignments. I think I looked on there maybe last night to see where everybody was, and there's several of you that are on it. There's a whole bunch of you that are not on it. Need to get on it. So that's another reason why we're having these meetings, because we want to make sure that people are not just sitting on this and then cramming all at once. That's a detriment to your education and is inappropriate for our program. So we are going to try to make sure that doesn't happen, and certainly encourage that not to happen. So that's that. Now, if down on the left hand side here, if you go to review material, you have all of these books. And again, I'm an administrator with the ABC. So, I have access to probably some things that you won't have, but the majority of this, I believe that you guys have. So first of all, when you look down through here, you see the 2020 stuff. We are using 2023 NEC. If you happen to have a 2020 NEC, a 2020 NEC, there are changes, of course. Does that totally defunct your education and you can't use that book? No, not necessarily. It would all depend on exactly what we were studying on. But as you go down through here, numerous other books that you can be looking at. But for example, the one that we're going to be looking at tonight, 2023, Understanding the NEC Volume 1. And if you open that up, you should see these tabs. I don't know if you get answer keys or not, but you have the book, presentations, and videos. And some of you might be thinking, hey, I don't remember seeing the presentations tab last time I was on there. Well, because I was told that it wasn't on there, and I contacted Mike Holt Enterprises yesterday, and boom, it's on there. So now you have, if it's a Mike Holt book, you have the book itself on here in electronic form. So, click on, I'm clicking on, let's see, wiring and protection, Article 210, branch circuits. Pull that up. And there's the book itself, to where if you're out on a job site or you're remote, what have you, and you want to try to catch up on some reading, you can do this, in electronic form. It's on here. And then of course presentations, same thing. Article 314, boxes and conduit bodies. There's the PowerPoint presentation, so you can actually review those. And then the videos directly, as you're doing your work, and many of you already know this, as you're doing your work on the what I call the weekly assignments, there are little tabs where you can click on and it'll open up a video. There are also these where there are, probably some of the same videos, also some that are maybe more expanded. So I'm looking at 314 boxes and conduit bodies. And of course, there's videos in there.
Article 314 boxes,
And I'm
conduit
sure
bodies.
that they are varied in length depending on the subject matter. This one is an hour and 24 minutes long. But nevertheless, some of the ones I think are probably little short ones. I know Brian House with Mike Holt told me that they were working on really creating more little short nugget videos of different little bits of information. I'll tell you something else while I'm at it. Mike Holt himself has started doing some videos that they've kind of showed up in my social media, but I'm sure you could probably find them easily enough. And they're like maybe 1 minute, maybe 2 minute videos, and they're all just little code nuggets, grounding and bonding, equipotential bonding, and just different things all over the board. Great little nuggets to get you more and more familiar with the code. So, you can actually look for those outside of this. So, and then, of course, if you get to go back to classes here, I'll show you. Well, let's see. Let's pick another class here.
Excuse me, sorry to interrupt.
Yes.
When I log in a capacitor, it says that there's no classes found, and I also haven't received any of my materials yet.
Okay. And and what contractor do you work for?
Design and build electrical engineering.
And you have not received your books?
I haven't received my books, and when I log into capacitor, it says that there's no classes found.
Have you? When did you enroll? Let me ask that.
It was a couple weeks ago. It was right before the official start. It was back at the end, towards the end of August.
Are you a remote? In other words, you're out working out of town?
Yes, sir. Yes, sir.
Okay. You should contact your office because I believe they have your books.
Okay.
Yeah. Design and build. Yeah. As a matter of fact, I believe they have your books.
Okay, right on.
I have notes on a few different people. I mean, I basically am handling all 4 years at this time. And so, got a lot of notes on that. Pushing out all the books has been obviously rather a bit of a challenge. And, we also had some last minute enrollment. Enrollment is now closed, of course. And so I think there's a last push out of books. But I invite you to contact your office. If for some reason you don't get, let's say, the answer that you want to hear, contact me. Send me an email and say, hey, just to let you know, I did contact my office, like you said to Mike, and let me know what they said. Because I remember talking to them, and to be honest with you, without my notes in front of me right now, I'm in presentation mode. I don't remember what it was, but it seemed like we had sent them directly to their office. We had a few different contractors that we sent them to their directly to the students. We had some that we sent just a big package to their office, and you can imagine everything in between. So let me know. And I would assume that everybody knows how to get a hold of me by now because that's all in the orientation video and my email address. So please email and let me know one way or another, quite frankly, if you get it squared away or if you don't.
Okay. And then are you able to check if I'm in your class? Because capacitor says that I'm not in any class.
My guess would be is that it is that you're probably not checked into the class. Hang on a second. You're going to make me do this on the fly, ain't you?
I apologize.
I'm not afraid. I can do it. Let's see. Zachary Ewan?
McEwen, yeah.
Oh, is it McEwen? Oh, okay.
Yep.
I
MC.
wrote it down and then my pen was laying over top of your name. Everybody else just relax for a minute, think about the code. I'll be right with you. This won't take a second. Literally, it's not a bad idea because I can kind of show you what I think it is. Zach McEwen right there. You see where there's not a check mark?
Yep.
There is now.
Alrighty.
Welcome
Thanks,
to
sir.
the jungle, my friend.
I appreciate it.
You're in. And that's, straight up honest with you. Holly Baker, our apprenticeship coordinator, she's the one that enters all the students in there right now. Again, I'm sure I told you guys this in orientation. I mean, we have a record enrollment this year. We're like well over like 560, 575 students. So Holly enters each and every one of those. So if she missed one check mark out of all that, that's not bad. So,
I appreciate it, sir.
okay.
Thank you.
Hey, no problem. And if you'll go back in, your class will show up for you now. So
I just got
I'm gonna,
the
and
email.
maybe I should have stopped with that. I was going to kind of do that at the tail end of it, but it seems we got a few more people in here now. Is there? Let's go ahead and do housekeeping, folks. Has anybody else got any issues like that? You got book issues. You got, like your work's not showing up. Anybody else in my class tonight have that issue or anything they want to tell me? I'm listening. I will take your stark silence as everything's okay. All right. All right. Well, and I think this class, it looks like, I believe almost everybody's in this class. Seems like there might be a few more. My intent, and that's what I'm going to get to here in just a second. My intent is to bring more engagement in this. I know for some of you guys that have been with us, maybe you've been with us since the beginning. We didn't start out that way, and our e-learning program is really, really expanded. So our intent is to make sure you're getting some bang for your buck, and make sure that we want to have more engagement with our students. The course obviously is a whole lot of you doing the work online, but our intent is to have more engagement so we can increase our ability to maximize what you're getting. You guys being third year apprentices, I am always and always will be under the assumption that, first of all, you want to be a licensed electrician. You're out there getting your OJTs. You want to get your education portion of this too. If you're in this program, more than likely you are a part of a traveling base, or for whatever reason, you're not, maybe wherever you are, you weren't close to a facility to where you could actually attend face-to-face class sessions. So that being said, here we are. So we're certainly going to try to maximize this the best we possibly can. So now I kind of back up here a second. I want to do the code graphic. One thing I would like everybody to get in the habit of doing, and this is a daily thing, and you can probably pull it up on your phone, and that is looking at the code graphic of the day. Our goal is, of course, to make individuals who are technical savvy, but also very much code savvy as far as understanding the code and knowing what they need to know as an installer or tradesman in this particular trade. So if you look at the code graphic of the day, there are two references on here. The first one is box fill volume calculations or internal cable clamps. Article 314.16, which if you're familiar with that article, and you should be, Article 314.16 or Table 314.16a is metal boxes. And that table gives all the metal boxes for, well, not all of them, but it gives you a lot of the standard metal boxes. It gives you the cubic inch space, and it'll also give you the amount of conductors that can be installed in that box. That's a whole nother subject for another day, but our code graphic here is indicating the internal clamp. Now, where would you see an internal clamp? If you look at the pictures here, not the box on the left is actually what I would call a cut-in box. And those boxes, when they are using non-metallic sheath cable, they will have a clamp inside of them. Most of the time, there's a clamp in the top and the bottom. So that clamp, when calculating the volume for your box fill on that, would be calculated as one volume. So if I have a number 14 gauge wire in that box, that means that if I go to table 314.16b, that table says that 2.00 cubic inches would be allotted for a number 14 gauge wire. So when I'm totaling up the cubic inch space needed for that box, I would also include 2 cubic inches for the clamps that are in that box. Keep in mind when you're calculating box fill, your equipment grounding conductors up to 4 conductors are calculated as 1. So that would be 2.00 cubic inches. As you see in the box there, you have 2 hot wires, or 2 blacks and 2 whites. So each one of those, that's going to be a total of 8 cubic inches. Your equipment grounding conductor, so that makes it 10. You've got an internal clamp, so that's going to be 2 more. So that's going to be a total of 12 cubic inches in that box. I put a device in that box. I'm going to put a double volume on that device, because that is what the code states, that you would use a double volume of whatever the largest conductor is in that box. So now I'm at 12, that's 13, 14, 15, 16. I'm in a total of 16 cubic inches for that box. I'm not really sure off the top of my head what the cubic inch space capability is of that particular cut-in box, but I would say, for example, a standard 22 cubic inch one gang plastic nail-on is oftentimes around 22.5 cubic inches. So at 16, we're certainly well within the confines of what that box is capable of doing. On the other hand, on the right-hand side there, it says cable connectors with the clamping means located outside the box do not count. So if you were using a standard, the classic 2-screw metal Romex connector, or maybe a black, I call them snake eyes, the black snap-in connectors where you can run NM cable directly through those. If you were using those do not count. Clamps entering the box like that do not count. The remainder of that box, the wire nuts do not count. Pigtails coming off of any splices made in there do not count. So just a little nugget on that on box fill for you. On the right-hand side, it says panel boards blank be installed in the face up or face down position. And the options are shall not or permitted to, listed for such purpose. It is shall not. Panel boards shall not be installed in the face up or face down position. And I'll tell you where that comes from. If you happen to have your code book, you can look at Article 408.43. And I would also recommend when you attend these classes that you always have your code book with you. Panel board orientation, because we are going to look at the code book in these classes. Panel boards shall not be installed in the face up or face down position. And if you, in your 23, it will say or face down in its grade. That is an addition. That they are not allowed to be faced up, face down. Now, you might be wondering, what the heck are we talking about here? So let me show you. Now, if we look at Article 48.43, panel boards shall not be installed in the face-up position. That's a 23 slide. That's from the changes from the 2023 edition of the NEC. So installing panel boards in a face-up position increases the likelihood that contaminants accumulate on the circuit breakers and panel board bussing, creating a hazard, obviously. Additionally, creates a challenge with applying workspace requirements, and new text prevents the installation of panel boards in the face-up position, and no current devices would be allowed on such a panel board. So this is from the 2020 changes. And it should be noted that this new limitation does not prohibit the mounting of the panel board in the face-down position. Aha! As I said, this change is from the 2020. So here is kind of an example of where, and I've got a picture here following that shows mounting a panel face up. So, obviously this is in a laundromat. Check this out. So this is a a laundromat where you have, you got like a row there where you got the washers on this side and the dryers on that side, and then you have this framed system that is probably pre-manufactured for laundromats running down the middle. Notice here in the top there how there is a panel that's facing straight up, which is nuts because you do not have the from 110.26, your approved clearance in front of it. Your clearance should be at least 6.5 feet, I believe, in height, and at least 30 inches or the width of the equipment, whichever is greater. So, a panel might be, 14 inches wide, and if the equipment was wider than that, then wider than 30 inches, well, then, it should be that width. But the width of the equipment or 30 inches, whichever is greater. Well, obviously you don't have that there, and you certainly don't have that sort of clearance. I don't know how you would get up there and kneel over the top of it or whatever in order to access that. But so that's kind of crazy. And to top it all off, the giant water pipe there right next to it. And I do not believe that that's a 3R panel. I'm pretty sure that's indoor. So, all right. So this is a nice little example. Make sure I'm clicking on the right thing here. A little code reference. Now, I'm going to jump down to, and mind you, these meetings, I'm not going to make them hours long or anything like that. The maximum typically will probably be an hour meeting. So you can pretty well count on that unless we get to talking or interacting about something. I'm not trying to cut them off, but that's kind of where we are. I'm going to pick up in one of the modules that is Article 430, and we are talking about Article 430, which if you look in your code book, Article 430 is going to be motors, motor circuits, and controllers. So I wanted to barely just kind of pick out a section here and talk about conductor ampacity. I believe if I can get to it, maybe overloads. Typically what we're sizing when we're talking about motors is I believe for the installer is oftentimes you're sizing your conductors, you're sizing your short circuit current, short circuit and ground fault protection, and overloads. And there's a lot of variety to that. So I'd like to kind of pick out this one section and discuss it. So conductor ampacity. So for continuous duty motor applications, branch circuit conductors to a motor must have an ampacity of not less than 125% of the motor's full load current as listed in tables 430.248 and 430.250. Those tables are giving you the ampacity which is specified for those motors. It's not from the nameplate. So branch circuit conductors, this is 430.22. Branch circuit conductors to a motor must have an ampacity of not less than 125% of the motor's FLC. So we'll jump into a couple of comments here. Circuits rated 100 amps or less, conductors are sized to the 60 degrees Celsius column of table 310.16, where equipment is listed and identified for use with the conductors having at least 75 degrees Celsius temperature rating. The conductors can be sized at 75 degrees Celsius column of table 310.16. Circuits rated over 100 amps, conductors are sized to the 75 degrees Celsius column of table 310.16. That's an important slide right there. Motor applications are considered continuous duty unless the nature of the control or apparatus the motor drives is designed so the motor will not operate continuously under load. When a motor is not continuous duty, because of this type of application, the conductors are sized using the percentages of table 430.22e, which is running down through my code book here. Table 430.22e, duty cycle service. So, real quick question here. What size branch circuit conductor is required for a 3 horsepower, 230-volt single-phase motor in a continuous duty application where the equipment is rated for 75 degrees Celsius conductors? First of all, from a test standpoint, oftentimes you're going to see that temperature rating given. What that's doing is that's taking you to the column you need to be when you get to 310.16. So, let's just see what they say here. So, the FLC, first of all, the FLC is in the NEC. I would write that down. The full load current is what you are sizing. Overcurrent protection, ground fault, and short circuit protection is sized based on the FLC. Now, there's some caveats to that, but that's the essentials of it. Also, branch circuit conductors to a motor must have an ampacity of not less than 125%. That means when you're calculating the motor overcurrent protection and you're in the conductor sizing, you're going to take that ampacity and multiply it by 125%. We have some other factors involved here, but that's the baseline. So 17 amps, which comes from 430.248. FLC times 125% is 21.25. Number 12, AWG, rated at 25 amps at the 75 degrees Celsius column would be your correct conductor size. What size branch circuit conductor is required for a 7.5 horsepower 230-volt three-phase motor, 75 degrees Celsius conductors? Again, coming from the FLC, which if you flip over to those tables, I need an overhead camera here. I may actually get one. If you look at 430.248, that is single phase alternating current motors. Table 430.249 is the FLC for two-phase alternating current motors. Not likely you're going to use anything out of that table. And then, booyah, here you go. Table 430.250, FLC for three-phase alternating current motors. That's where you want to go. Now, this one, I believe, was this was a three-phase motor, so it's a 7.5 horsepower motor. And if you look across the top there, it says induction type squirrel cage and wound rotor motors. And then the voltage, what was our voltage on this one? 230 volts. So 22 amps. At 125% gives you 27.5 amps. Back to 310.16, that's going to put you at a number 10 gauge wire, which is rated at 35 amps. Now, I'll stop for a second there and say, in 240.4D, I believe it is where you'll see small conductors. And, anyone working in the trade and in third year should know the basic ampacities of your basic conductors. 15 amps, number 14 gauge wire. 20 amps, number 12 gauge wire. 30 amps, number 10 gauge wire. Those are the basic conductor sizing, right? Well, if you look at table 310.16, depending on what column that you are operating out of, will depend on that basic ampacity. For instance, a great thing to just make a note of for testing things in the future is NM cable comes from the 60 degrees Celsius column. When you are sizing conductors and you're looking at branch circuits that are going to be in that realm, in other words, a residential single-family dwelling or apartment building, multifamily duplexes, the residential sector, you would be in the 60 degrees Celsius column because you're more than likely using NM cable. So sizing conductors at that point would be there. Otherwise, I would say from a testing standpoint, you would see that given in the question in order to make sure you were in the right spot. For short-time, intermittent, periodic, or varying duty applications, branch circuit conductors to a single motor must have an ampacity of not less than the percentage of the motor nameplate FLA rating shown in 430.22E. So now, I'm going to skip to this one here. Other than continuous duty, where did this 85% come from? Well, if you flip over in 430.22E, duty cycle, 85%. Well, where'd that 85% come from? Well, if you look back in their question, they say it is a nameplate FLA of 29 amps, rated for 5-minute service, used for intermittent duty where the equipment is rated for 75 degrees Celsius. So that tells me that is, if you look in that table in 430.22E, it says the nameplate current rating percentages, and you have a 5-minute service. Well, there it is right there, 5-minute rated motor. We have let's see, used for intermittent duty. Okay, well, you look at the descriptions, the classification of the service on the left-hand side, intermittent duty, 85%. Once you've done that, 29 amps times 85% gives you 25 amps, or 29 amps times 85% gives you 25. That being said, from table 310.16, that's going to give you a number 12 AWG conductor rated at 25 amps. Now, before I keep rambling on here, I just want to stop and hit the off ramp for a second and say, I am always under the assumption that individuals who are in these classes want to be licensed. Or even if you already have your license, and I think there's a couple of you in here that do have your license, you need to know how to do this. Some of you, well, let's face it, you're going to end up doing work that you may actually have to do this kind of calculations to determine what's going on. You don't always have everything just laid out for you. You don't always get a sweet set of prints that just says follow the bouncing ball, do this all the way to this, and you've covered everything. You may have to actually figure some of this out on your own. Sometimes you show up and they say, we want lights in this building, or we have these loads and we need to make sure that what we install is properly sized and properly protected. That's where this is. Motors is a big deal. When you're taking your journeyman's exam, there's a distinct possibility that you could do motor calculations. What the journeyman's exam is the individuals who's running pipe and pulling wire and making decisions like that. The reason that I don't think you would see a multifamily or a calculation for a service on a commercial building in a journey level exam is because that's not what the journeyman's doing. That's for the master. So, if you're testing at that level, different story. But at this point, the calculations that I think you could encounter on that test would be things exactly like this. I'm sure in the coming weeks, I'll bring back around some other material that I have that teaches some other calculations really under the heading of load calculations in general, just doing basic circuit calculations and things like that. So let me ask, just trying to figure out how we can do this. How many of you would need to take your licensing exam? If you can do that, let's see. What about you raise your hand? How many of you, and hopefully you're all listening, Tim Smith would like to take his licensing exam? Thank you, Tim. Jared, Kevin, sorry if I'm mispronouncing your name. James Cagle, Lucas, David. All right, as I thought. Dante, Josiah. Very nice. So you'd like some more information on how to go in and do that one time and knock it out and be done with it, right? That's what I thought. So good. Then we have an agreement. Let's see if we can do that. So, when I'm teaching these classes, obviously I see all these lovely icons. I'm pointing to. I have two screens here. You probably don't see that. And I'm looking at the picture of me right now. Obviously, I'm in my beautiful condo down in Boca Raton. Love these backgrounds from Teams, Microsoft Teams. But I've taught a lot of exam prep classes. I just finished one up for the Ford Motor Company this summer, and I've had a lot of guys coming back to responding that have passed their exams. So if you guys are interested and you want to engage in these and come to these classes, and I'll even have more if you're interested. We'll help you make sure that you do that. For the couple of you that I know are in the class that have already got your license, just because you passed the journeyman's exam does not mean that you arrived. I can tell you that. There's a reason why the licensing requirements in the state of Kentucky, and I know I got guys probably from all over the place, but we're talking Indiana, Kentucky. That's where I'm at. Licensing requirements for the state of Kentucky. You go to 2 years of federally approved apprenticeship programs. You get 4,000 hours of OJTs. You pass your journey level exam. You can have an EE level license. EE level license is essentially a journey level license in Kentucky. But the state law also says you have to complete years 3 and 4 in order to maintain that license. So let's say you do that. You get your license in Kentucky. There are, I think, at least 3 states here regionally, and I apologize, I can't remember which ones they are. I want to say it's the Carolinas, maybe Ohio, that reciprocate with Kentucky. Because I know some of you guys, you're in this class because you're travel based. So having a license here in Kentucky, that would be good. Having a license, and now you can actually reciprocate with a couple other states. So now you hold license in a couple other states. That's a nice feather to have in your cap, isn't it? We can do that, and we will throughout the year. We'll end up talking more about this. We'll even look at getting some information to you about that. I don't, It's hard for me to tell, guys, for where any of you guys are. We have so many different people in this program from different areas. I know we have people from the Carolinas, from Kentucky, Indiana, Michigan, Florida, Texas. You know, depending on the class, it's pretty crazy. We started this program, and it really is exploding. So, moving on. Several motors, conductor ampacity. So conductors that supply several motors must have an ampacity of not less than the sum of the following. And that is 430.24. And you look in your code book under 430.24. First of all, under 430.22, which was mentioned earlier, single motor. Conductors that supply a single motor used in a continuous duty application shall have an ampacity of not less than 125%. Have it in your head that you have to calculate that ampacity from the tables in the NEC times 125%. Keep in mind, and the slide will come up here soon enough, I think, that says this, we are not talking about overloads. You calculate the overcurrent protection and conductor sizing for a motor based on the FLC from the tables. You size overload protection for a motor from the nameplate rating. That's the difference. But 430.24, several motors or motors and other loads. So this is the caveats for this. 125% of the highest rated motor FLC. So if you're calculating, essentially what this is saying, you got several motors, and I don't know if oh good, they do give me a slide for this. So check out this graphic. You've got a panel that's feeding all this. You jump out and hit a trough. Now you're dropping down, and you have your overcurrent protection device for each one of these motors, and then you've got your motor starter there next to it, and then flex coming down to the motor. So you can get the picture here. But you're feeding this all with a subfeed and then splitting out from a trough to each one of these motors. How do you size those conductors? How do you decide what size wire to run to all of these? And then you're able to split off. And what size overcurrent protection device you put in that panel. This is how you do it. Essentially what you're going to do is you're going to go to the tables in the NEC, take the motors, and go, okay, this motor, if you look at there, it says largest FLC. So the motor that is a 15 horsepower motor, 230 volts, three-phase, the FLC is actually 42 amps. Keep in mind, whenever time you see a bunch of motors like that, especially in a test question, just because it's the highest horsepower doesn't mean it's the highest ampacity. But 15 horsepower for a 230 volt three-phase, that's the largest one. The other one there is 7.5 horsepower, and it's 22 amps. So we're going to take that largest amount. And they didn't do the calculation for me. Anyway, I'll just tell you. They're going to take that 42 amps, multiply it by 125%, and whatever that ends up being, we'll take that and then the ampacity of the other two motors. So I would take 42 amps times 125, 42 amps times 125%. That's 52.5 plus 22 amps plus another 22, because there's two of them with 22 amps. That's 96.5. So at that point, I can say, okay, I've got a load of 96.5 amps. Now I can go to table 310.16 and size my conductors. Now I'm ready to install. Whenever we're calculating, we're determining this. I'm telling first-year students this, the same thing. It's all about determining the ampacity, because once I've determined the ampacity, then I can size my overcurrent protection. I can size my conductors. Then I can size what size pipe I'm running. I can build the job. So the motor nameplate FLA rating from 430.6A2 is not permitted to be used to determine the motor feeder conductor ampacity. We're talking about the motor feeder. What size feeder conductors are required for a 2 horsepower single-phase 230 volt motor and a 5 horsepower single-phase 230 volt motor where the equipment is rated for 75 degrees Celsius conductors? So here again, we're taking the calculation because we have a 5 horsepower motor that has 28 amps times 125% plus the 12 amps that's for the other motor. That gives you 47 amps. You go back to the, and it also, from a question standpoint, they're saying, okay, the terminals in this equipment are rated for 75 degrees. Well, that just told you what column you need to go to in table 310.16, didn't it? 75 degrees Celsius column. We're going to go with number 8 AWG, which is going to be rated at 50 amps. All right. So I think for time's sake, I'm going to skip ahead a little bit and stay on a subject here, so just stand by. I don't want to get into motor overloads. I think I'd like to keep staying on the same theme here. And I won't keep you unduly. Don't worry about that. I'm respectful of your time. I'm going to hit branch circuit, short circuit, and ground fault protection, and then we'll call it. So a branch circuit, short circuit, and ground fault protective device protects the motor, motor control equipment, and branch circuit conductors against short circuits or ground faults, but not against a motor overload. You have to understand the difference between overcurrent and overload. I always use the analogy that overcurrent obviously is it's short circuit or ground fault protection. In other words, when you have two hot wires to come together, or a hot wire and a grounded conductor or the neutral come together, I mean that's ground fault, short circuit type scenario. Overload, I would liken it to, let's say you've got a motor that's running a conveyor belt, and you're putting cardboard boxes on it that weigh 10 pounds, and it's just moving along. Then you put an 800-pound box on this same conveyor belt, and this motor is driving it, and that motor is going to drag down. What keeps that motor from being torn up or destroyed are the overloads. They're going to kick out, shut that motor down before it's destroyed. So that is the quick description between those. So short circuit and ground fault protection is designed for fast current rise, short duration, fast response time. Everybody in this meeting by now has tripped a breaker, and that's exactly what it's for. Short circuit and ground fault protective devices are intended to protect the motor, motor control equipment, and the branch circuit conductors against short circuits or ground faults, but not against overloads. The motor branch short circuit and ground fault protective device must comply with 430.52B and C. And if you got your code book, we're going to jump over a little bit here. Go to 52, which table 430.52C1, maximum rating or setting of motor branch circuit, short circuit, and ground fault protective devices. And in that table, 430.52C1, you have on the left-hand side, if you're looking at it, you have single-phase motors, AC polyphase motors, squirrel cage motors, design B energy efficient, and then you have 4 different categories: non-time delay fuses, dual element time delay fuses, instantaneous trip, and inverse time breakers. So, but I'm showing you kind of a strategy here, guys, because when you look at this, I don't know if there's any gals in here, look down that non-time delay column. You've got 300%, 300%, 300%, except for the last 2 types of motors. Dual element, 175 until the last 2. Instantaneous trip, 800 until the last, you got 1100 there for design B. Then it goes back to 800 and 250. And then inverse time breaker, 250, all the way down to the last 2. My point being is this. If you look at it that way, the law of averages of you're calculating this, you need to know that circuit type. They should be giving you in a test question the type of motor, and then you can nail that percentage. Once you've done that, and I'm sure we'll do a calculation here in a second, motor branch circuit, short circuit, and ground fault protective device must be capable of carrying the motor's starting current. That is the issue with motors. You probably already know this, but when a motor starts, it's going to ramp up really high, and then it'll level off. But the overcurrent protection device has to be able to deal with that. And here's a little graphic showing that. Bang! It goes up really high, and then once it, and I mean this is milliseconds, but once it takes off, then it's okay. But that overcurrent protection device has to be able to deal with that. Motor starting current. When voltage is first applied to the field winding of an induction motor, only the motor winding resistance opposes the flow of current startup. Since the only resistance during motor startup is the winding resistance, the motor will typically have a starting current 6 times the motor nameplate running amperes. I'd make a note of that 6 times also. Running current. Once the motor reaches its rated speed, the starting current reduces to running current due to the counter electromotive force induced in the motor winding. This is caused by Stator's electromagnetic fields cutting across the armature motor windings. And the motor branch circuit must be protected against short circuits and ground faults by a protective device rating or setting no greater than the percentages given in the table I was just telling you about, 430.52. The FLA rating is not permitted to be used to determine the motor short circuit and ground fault overcurrent protected device. And hopefully you can see that, to where most people would go, oh, I got this motor. Look, there's a nameplate on it, and it says what the ampacity is. That's not what you would size your overcurrent protection on. How many times do you think that mistake gets made? And another little nugget about motors while we're on the subject of it, if you look at a motor that has, it's a dual voltage motor. In other words, it could run on 115 volts or it could run on 230 volts. If you look at that motor tag, it will say, let's say it's going to run at 115, it's going to pull 20 amps, just making something up. But if you actually connect it to 230 volt power supply, it will run on 15 amps. The higher the voltage, the lower the amperage. That's why when you go into like a commercial building, that's why they will have the larger loads on a higher voltage. For example, like the school I teach in, all the lighting, literally all the lighting in the building is 277 volt. That's because if you operated all that same lighting on 120 volts, it would actually be more costly to operate. If you go from 120 to 277, I mean, I could show you the Ohm's Law calculation on that and see what a light fixture pulls. It is quite a bit different when you're operating at a higher voltage. That's why we do that. Same thing with motor loads, large HVAC loads. That's why in buildings you bring in 480 volts. It's for those larger loads, and then you drop things down for regular, general purpose stuff. So the motor branch circuit must be protected against short circuit and ground faults based on 430.52. And here's a little nugget of that table. They kind of do a condensed version of it. The non-time delay, the dual element, the inverse time breaker. We're not really on overcurrent protection right now as much as, like different types, but these are the types you would need to be concerned about regarding the calculation. I'll say that. According to Article 100, inverse time circuit breaker is purposely designed to delay its tripping action during an overcurrent condition, and the intent is to compensate for the inrush current during the normal startup. Inverse time circuit breakers operate on the principle that as the current increases, the time it takes for the device to open decreases, and they provide ordinary overcurrent protection during overload, short circuit, or ground fault conditions. This is the most common type of circuit breaker purchased over the counter. And here's a circuit breaker. I don't know if you've ever seen a breaker like that. Notice there's not, if you saw like a ground fault breaker or a arc fault, there'd be circuit boards inside of it. This, it's a mechanical device. Notice the arc chute in the back. Just like the little breaker's butthole. That's what it is. And if you've ever done this, you got a dead short or something like that, that's pretty much where the fire chute's out at. Which that's what that's for. You have a fault or something like that and you turn it on, and some of you guys probably seen that where you all have seen, whoa, there's some flame inside there, a little blue flame. That's where it's coming out. It's like eating Taco Bell. Okay. Oh, I want to go back to that slide. It bothers many in the electrical industry, this is kind of funny, to see a 14 AWG conductor protected by a 40 amp circuit breaker. You see what he's talking about? But branch circuit conductors are protected against overloads by the overload device, which is sized between 115 and 125% of the motor's nameplate current rating. The rule that limits 15 amp overcurrent protection for 14 AWG conductors does not apply to motor circuit protection. Okay. A couple more slides and I'm almost done. What size inverse time circuit breaker is required for a 5 horsepower 208 volt single phase motor? So the breaker would be FLC times 250%. And that was an inverse time circuit breaker, I believe it was. Yeah. So I'm looking at my table here, 430.52, inverse time circuit breaker for a single phase motor, I believe it was. Yeah, 250%. So you went and taken the from the FLC and the NEC, you went to 430.2, let's see, 248, and that motor pulls 30.8 amps times 250%. So now it's 77 amps. So now we've got the next size up per 240.6A, which is your standard ampere ratings. That means I'm putting a 77 amp breaker on a 30.80 amp load. So where the values from 430.52 do not correspond with the standard OCPD rating, the next higher OCPD ampere rating or setting can be used. Where that reverses is overload protection. When you are calculating, you get to the point with overload protection, you cannot round up. It goes down. Okay? Remember that the 80 amp circuit breaker is providing short circuit and ground fault protection, and the motor overload device set at 125 or 115 on the FLA will protect the motor equipment, and motor circuit conductors against loads. We are continually installing stuff that is protecting against ground faults, arc faults, short circuits, overloads, overvoltages surge protection. And that's what we are installing equipment to keep that from happening. To the, as they say, the lightning that we're putting in these systems, all this stuff that we're shooting out in these buildings, this is the stuff that protects it from, getting away, getting out of control. A motor can be protected against overload, short circuit, and ground faults by a single overcurrent protective device sized to the overload requirements. That's also true. And I think that's where I'm going to stop. So, it's 21 after. I'm going to go ahead and just stop and see if everybody has any questions for me, and then we can call it. So, anyone have any questions or comments, complaints? Okay. For any of you guys that haven't gotten started on your work, I would assume that you don't have a problem, that you do have books, and that you do have, I think I fixed one guy had access. He said he had no books, but I think I know what's going on there. So I'm assuming everybody else in this class is good. No one else has contacted me. So I'm getting a thumbs up from Zachary. So awesome. Get to work. Don't let this stuff pile up on you. You have a lot. I'm going to be straight honest with you and say level 3, there's more material in level 3 than any other level of the apprenticeship. So sorry. Deal with that. So you got a lot of material to cover, and some of it, we kind of go into the tall weeds, so to speak, of the code book. So be prepared for that. You don't want to get behind on it. So stay on top of it. We're going to continue to have these meetings. From our meeting tonight, I'm really gleaning that you guys are interested in getting as much code out of this as possible. Talking about exam prep and things like that. I'm all about that. That's one of my favorite things to teach. So we will plan on that as we continue throughout the year. So I'm going to say until our next meeting, which looks like on the 23rd. Is that right? Yeah. Looks like it's on the 23rd. I'm looking at my calendar. If you have any questions, feel free to email me at mike@abcindianakentucky.org. And you guys have a great evening, and we'll see you in the next meeting. Thank you. You guys have a good night. Thank you very much, Carter.